Right. Yeah, I cannot write two. So sorry. Yeah. I hope you can see what is below here. So this is how we construct the counter set, and I'm going to prove it is closed. So I have to prove that the complement of it is open. So the first thing I did is to prove that for each Cn is actually closed, and we already know that this interval, closed interval, is closed, and I want to know that the union of, for example, like multiple closed set is also closed. Okay, so this is how I prove it. So again, based on definition, we have to look the complement of this union set. For example, like A1 and A2 are closed, and I want to prove that the union of A1 and A2 is also closed. I have to look at the complement of the union of A1 and A2, right? So for all elements in the complement set of this A1 and A2 union, X must be because of the De Morgan's law, I have proved last Friday, the X must be within A1 complement and A2 complement. Okay, and because of that, I can find the epsilon 1 and epsilon 2 that is larger than 0, and open a small ball there that is be contained within that complement set. And why can I do it? Because based on the definition, or based on the condition we have, A1 and A2 are closed. So we already know that A1, the complement of A1 and the complement of A2 are open, right? So that's why I can write it this way. And because we can write it this way, the only thing is that I only pick up epsilon bar here, which is the minimum of these two, epsilon 1 and epsilon 2, and that ball is actually contained the intersections between these two complement set. Okay, and this is how we prove that the union of A1 and A2 is closed. That means Cn is closed. That means the complement of Cn is open. Okay, so that is the first step. And the second step is going to be that, okay, the final goal is going to show that this stuff is open, which is the union of several open set. We already have, we already proved that Cn is Cn, the complement of Cn is open, right? Now we are going to show that the union of several open set is also open. So it's actually quite similar. We prove in another lemma 2 there. So if A1 and A2 are open, and the union is open. So this is how I did it. So for all X in A1 and A2, we can find epsilon 1 and epsilon 2 that can open a ball that could be contained within A1 and A2 because they are open. And then again, you pick up epsilon, that is the minimum of these two, and open another ball that is to be contained within the union of these two open set. Okay, I missed the simple here. And because of that, we proved that the union of two open set is also opened. So by lemma 1, we know the complement of each Cn is open. And by lemma 2, we know that the union of it is also open, which means the original counter set is closed, and that finished the proof. Okay, continue. Then is the definition of limit point. So what is the limit point here? When we are in the metric space and that the set A is contained in the metric space M here, a point X is said to be a limit point of A if for all epsilon, like positive epsilon here, there is this small a within that set A, such that that small a is going to be contained within that open bolt. So what does that mean? It's kind of complicated here. Okay, so it looks like the graph here. First, we have the set A here, and we have a limit point X here. And according to our definition, it says that for all epsilon larger than 0, we can find a point in A and